All right, so I'm really sorry about the choppiness of this video, but my calculator here is like the free version, so I can't do regression on it. So I had to show you on my laptop. Okay, now that that's out of the way and I taught you how to get the equation here, the question becomes, will the ball go over the wall? And if not, will it hit the wall on the way up or on the way down? All right, so I think the best move here, because I like just love Desmos for this kind of stuff, we're going to write this equation in Desmos. Oops, excuse me. And because it's going to just be easier to look at it with a graph. Now you could use your calculator for a graph too. There's nothing wrong with that. Okay, so there's the equation. And I'm going to get rid of that. We can see, hopefully, we can see these points on, let's do a split screen here. That looks pretty good. I'm really hoping you can see those points on this graph. So if I go over here, you should be able to see the point of 1, 3 right here, okay? And you should be able to see the point of 2, 5 right here. And you should be able to see the point of 3, 6, which is right here. Okay, now what I'm going to do on Desmos is I'm going to plot where the wall was. And the wall is at 5, 6. So I can, with Desmos, label a point of 5, 6. I can even put a label on there and just call it the wall. And we can see that on here. So the question is, will it go over the wall? And the answer is no. And you can see that there in the graph. So I'm going to write no, because here's my parabola and here's the wall. So it's not going to go over the wall at all. And then it says, will it hit the wall? Now, if I could draw a straight line here, I wish I could. You know what I can do? There we go. I'll just insert the picture here because that will be easier for me to write on it then from Desmos. That's this one. Okay, I'll crop it to what I need. Sorry, I'm trying to do this fast because I know you don't want to watch it too much. There you go. It's always fun to watch me struggle anyway, isn't it? Okay, that's what I want. Okay, now that I have this picture, is it going to hit the wall on the way up or on the way down? So there's the wall right there. See that purple line? That's the wall. So it's going to hit it on its way down. So no, it won't hit it. What was the question? Will it go over the wall? Sorry. It won't go over the wall. And when it's going to hit it, it's going to hit it on its way down. And you can see that because of the point 5, 6 is right here, which is where the wall happens. So the ball is going to hit it on its way, on the way down. Okay? So it's kind of nice being able to identify the graph that way. Let's look at example 3. We're going to compare. So it says, campers are at an aerospace camp and they launched rockets on the last day. Which rocket flew higher? Which one was in the air longer? So this one is rocket number 1 and this one is rocket number 2. Rocket number 1 is given to us as an equation where h is the height and t is the time in seconds. And unfortunately, this one's given to us as a graph, the second one. So this one is with an equation, which is a model, and this one's with a graph. So we have 2 different rockets, rocket number 1, rocket number 2. The highest height, well, that's just a really fancy way of saying maximum. So let's focus on rocket number 1. Yesterday, we learned that means just find your vertex, okay? Highest max vertex. That's opposite B over 2A, which is opposite B, negative 150 over negative 32. Get out the handy dandy here. Negative 150 over negative 32. Okay, so 4.6875 is my x value, but in this case, it's not x, is it? In this case, what is xt? So that must be in seconds. So this is the time. Now that's not the height, that's just when it happens. So in order to find out the height, I need to plug that time in. So negative 16 times my answer squared plus 150 times my answer plus 1. I definitely typed that really fast, so I'll just babble a little bit while you catch up with me. So I had to find negative b over 2a. That didn't solve for x in this case, it solved for t. And then I had to plug t in. And that's going to tell me my height. Negative 16, 4.6875 squared, plus 150, 4.6875, and plus 1, that little random 1. So the maximum height is 352.5625, and that is feet. That is the maximum height. Now the next one is just going to be a lot easier because it's a graph. Oh, this one's a lot higher. This one's just visually how high because it's just a perfect graph. So this one looks like it's going to be pretty darn close. I'm going to say about 575. So I'll say the max height is about, because I'm using estimates, 575 feet using my graph. So this one, obviously this one was a lot harder to find because I don't have a picture. This one was pretty easy because I had a picture. So which rocket flew higher? Definitely rocket number 2. The one that has the graph. Because we know that 575 is much higher than 352. Okay? And if you wanted to graph that, you could see that. All right? Which one was in the air longer? Ooh, that is kind of sneaky. That one's actually kind of a hard question. But I can definitely read the graph. So I'm just going to write rocket 1, and I'll write rocket 2. And rocket 2 is easier because you have a picture. See this time right here? Rocket 2 landed on the ground in 12 seconds. So it was in the air for 12 seconds, okay? Because we can see that that's when it lands. And we can see it lands because that's when it reaches 0. Now, rocket 1, what I'm going to do is I'm going to plug in 12 seconds. I'm going to compare it to 12 seconds. I will try 12 seconds and see what happens just to compare it to rocket 2. So grab my calculator, type it in my equation. I got to see my equation nice and close up. Negative 16, and remember I'm plugging in 12 so I can compare it to the other one just to see conceptually what's going on this one. Ooh, that's weird. So at 12 seconds I get a really funny answer. My funny answer is negative 503 feet, which is like, what? That's not like a thing. That's because it like would have already hit the ground. So it already hit the ground. Because, like, you can't have a negative height. In other words, like, if you were graphing this, it would have been like, boom, in 12 seconds. So clearly it went way past hitting the ground. So this question says, which one was in the air longer? Rocket 2, for sure. Because by 12 seconds, rocket 1 already hit the ground.